All right.
And can we display it here?
Yeah, give me 1 second. Five, 7, 3. All right. There we go.
All right, guys. So, welcome to a talk about artificial intelligence, what it actually is, and how can you learn it. I'm Ayush Garg. I'm a sophomore here at the University of Richmond, majoring in computer science with a minor in business administration. I'm also doing research on AI right now, which makes it slightly helpful. And I have Ryan here with me, who's going to talk over what are the AI tools that we can actually employ in our daily lives to get better as a student. But starting, we've heard the term artificial intelligence a lot of times before, right? Like it's been on everyone's mind. But what does it actually mean when you hear AI? What should it be that's going through your mind? Does anyone have an idea here? I just want some answers. Yeah, go on.
I don't know. It's going to take over. It's going to replace human intelligence. I don't know. So the dystopian part of it.
Okay. That's certainly a part of it that should be acknowledged. But I think in the very basic sense, artificial intelligence is a system that mimics human intelligence. So any system that can think and give an answer just in the very basic form, like in human would, could be classified under this umbrella term of AI. Now, obviously, AI is an umbrella term, right? There are many things that encompass it. Let's talk about some examples. For instance, chatbots, e-payment systems, smart cars. The biggest example we've seen of AI that I think has put AI on the stage right now, ChatGPT, that's also a form of AI. More importantly, though, AI is in more places than what you would initially imagine. When you search on Google and you suddenly get these links which might be suggested to you when you search, oh, how to, and it says how to cook an omelette, how to tie a tie. All of those are actually AI suggestions as well. Facial recognition, when you take a picture on your iPhone and it automatically makes it so that the background's very slightly blurred, even that is AI. Going further than that, if you talk about cars again and again, just do this experiment one day. Talk about cars consistently around your phone. The next day you're going to wake up and see on Amazon that there are a bunch of car accessories that come up. What is that? That is also AI, and we're going to learn about how that AI is actually made on a mathematical and a more fundamental level, so you know what's going on behind the scenes. Now, let's actually dive deep into what comprises AI, right? We know that it can take in an input and give an answer like a human would. But how does it do that? It's a very big mystery, but the answer is more simple than you would think. Imagine this graph right here. It has some red dots and it has some blue dots, right? Now, the new input is this orange dot, and we're trying to predict whether this dot would be red or blue. A simple example would be, let's say there's pictures of dogs and cats. This new image is something that the computer wants to put in the folder of either cats or dogs. How is it going to know that it's a dog or a cat? That's where the simplest AI algorithm, K nearest network, comes into play. Now, this dot here, let's see how close it is to the other points. This is just a graph and we've plotted this, right? This is the x-axis, this is the y-axis, and this is a random point. When we say k as 1, we're basically saying what is the nearest neighbor to this orange point. In this case, the nearest neighbor here is a red dot. So, the computer algorithm will say, okay, well, maybe the dot is red. I can say that the closest point to this dot is actually a red point. So there's a very high chance that this point might also be red. But let's set k as 3. Now, let's check the 3 nearest neighbors that it has. So obviously, we know it's very close to this one red point, but it's also very close to these two blue points. And it's actually closer to more blue points than it is to a red point. So the AI system might say, well, no, it actually should be blue when we set k as 3. Now we move one step further. We ask the question, what if we look at the 4 nearest points? Okay, well, it's close to 2 red points, but it's also equally close to 2 blue points. So the AI system doesn't know. Well, the point was actually red, as it may seem from the first example. But you might have this question, well, Ayush, you went over the point being red, blue, or either one. You didn't give us a defined answer of how this AI system works. Well, we're going to dive into that part now. Like, how do we decide what are the number of neighbors that we should decide for a system like this?
Can I just chime in here for 1 second?
Yeah.
There's a series of gig economy tasks on Amazon MTurk Mechanical.
Right.
Where you can actually earn like 10 cents a prompt, where you basically follow these slides and you identify dog, cat. At what point does a picture of a dog start to look like a cat? So these red and blue dots, you're actually, even though it seems kind of ridiculous to us, you're teaching an AI system how to identify this or that.
Yeah. And it's good that you bring that up, because, I was talking about how these K points are decided. Let's say you have 1,000 images and something like Mechanical Turk. And for those who don't know, Mechanical Turk is this system where actually human annotators sit and they get a small reward for classifying a picture or answering a very simple basic question. So then they can build this gold data set and actually train AI algorithms on top of that. But they're going to see that, well, when we set K as 3, we get the answers that are closest to the actual answer, right? Like cat, dog, oh, this new point, it's actually supposed to be a dog, and K equals 3 predicts that it's a dog. So that's how we choose what K value it should be. Now, these are KNNs. There's a lot of problems that you can solve with KNN. For instance, I once built an AI system that could predict what's the price of a house or what the ideal price should be. And it had parameters like what is the proximity to the nearest hospital? What is the proximity to the nearest garden? And based on those data points, you basically see, okay, well, the houses that are most similar to this house are going to be the most near to this, and what price are they? So it's the same as this problem. You're basically trying to see what are the nearest points to this and what value do they have. This system in particular is very, very good when you have a lot of data points that you have classified already. And now you have a new data point that you basically want to see where it fits into the picture. So you could have a bunch of students here and be like, okay, this student is classified into this course structure. This student is classified into this course structure. A new student comes, where do we place him? Well, we see what student or what student group is he nearest to. And then once we decide, okay, well, he's very, very similar to this group of students, well, that could be what course structure he wants to take. That's also an example of why KNNs or where KNNs could be used. Moving forward, neural networks. This is like the archetype of what AI systems have come to now. ChatGPT is based on this. All those Google recommendations you see are based on this. And even the cat and dog example, although it could be using KNNs, but more likely than not, it's using a neural network. So this is the golden state of what AI systems actually propose. And I'm sure you've heard about a neuron before, right? Does anyone know what a neuron is in the biological context or whichever context they've heard it in?
It's a bundle of nerves.
Yeah, that is actually correct. So a neuron is what your human brain uses to make connections between different things. And this sort of an AI system, neural networks, are actually based on how humans think. So humans have these neurons that have endings like these, and they're connected to other neurons. And somehow, magically, it all operates in a way where we can actually think of different things and come up with an answer. But now what we're going to do is actually talk about how does it make those connections? How do these dots interact in a way that is able to produce something like ChatGPT that people are amazed by? Now, just as a basic introduction, neural networks have inputs, right? In this very diagram, these green points are the input. So this could be a number and this could be another number. This is me saying, let's say you have a dog now. These are the number of paws the dog has, and these are the number of ears the dog has. Now, we don't actually know if it's a dog or not, but we have an animal that has number of paws here and number of ears here. Through the system, we're trying to predict whether the animal is a dog or not. So these are the inputs. These are the inputs to whatever you're trying to classify. For an animal, it might be the number of paws and the number of ears. For something like the housing market, it could be the number of hospitals it's near to, and here it could be the number of gardens near the area. So basically inputs for a variable that you're discussing. Then these hidden things, they combine these parameters in some way so that when you reach this point, it classifies into the right thing. Now, I'm sure this is a very confusing picture, right? Like, okay, what do these dots actually do? We haven't actually answered that question yet. How does the final result be into what it should be? To understand this, we need a deeper background into how these competitions take place. And we're going to talk more about that now. As we talked about in the beginning of the presentation, in the very basic sense, an AI system takes a question, it thinks, and it gives an answer. This black box right here is where the computing happens. Now, this could either be a KNN, as we discussed earlier, where basically there was a point being classified based on how many other points is it near to, or it could be a neural network. But basic thought remains the same. You give a question and it gives an answer. Now, a very basic example for this, which everyone could understand, could be the conversion from kilometers to miles, right? Let's say this is hidden right now. You're given 100 kilometers and you want to output miles. Let's play truth and guess here. Let's just pick out a random number. For me, I'll say 0.5. I just take an arbitrary value. This could be any number. Give me your favorite number right now. 14. This could be 14. This could be 100. And now I will say this AI system will put 14 in here, and that should give me my answer. Well, you're going to tell me, Ayush, no, you're dumb. 14 is obviously not the right answer because 14 times 100 is 1400 and not whatever the correct answer should be. So I chose 0.5 as my favorite number. And I was like, well, let me just put 0.5 in this thinking box right here. Take any number, multiply it by 0.5, and then give me the answer. We'll go on from there. So it said 50 miles. Now bear with me here. This is a model trying to do something. This is a very simple linear model, and having a good understanding of a linear model will help us understand neural networks better, because neural networks are a bunch of these things joined together. Now 50 is obviously not the correct answer. The correct answer is actually 6.137 miles. Let's take this number 50, what we guessed with our very basic AI system, and let's take the actual answer. What is the difference in between both of those quantities? It's 12.137. And for an AI system, this error is obviously not good. It's very terrible, if I may. So 0.5 should not be what this AI system should be doing. Let's take another guess. Let's just say instead of 0.5, we were close. Let's just bump it up just a little. Let's put it as 0.6. So 100 is the input. 0.6 is this weird thinking box, and it gives me 60 now. Well, the actual answer was 62.137. So the error now is 2.137. Better than whatever the error back there was. Now I say, okay, going up is making this thing ever so slightly better, starting from 0.5. Let me go up one more step. When I go up one more step, I get 0.7 here. So 100 times 0.7 is 70 now. The actual answer was 62.137. So the difference we get here is minus 7.8. Oh, well, this is actually way worse than the 0.6 which we put in there. So now our AI system sort of knows 0.7 is too high. 0.6 is nearing the correct answer. It's just slightly short. So what I'm going to do now is just pick out random numbers between 0.6 and 0.7 to see if that's my guess. I choose 0.61. I reach a value of 1.137, and I'm satisfied with my AI model. I'm like, okay, if we take 100 here, and if in this black box, all we're doing is multiplying the number by 0.61, we get an answer that is very, very close to the correct answer. You, my friends, have designed your very first own AI system. This is in conceptuality very much what an AI system does. It picks out random numbers as this parameter, and it tries to fiddle with them in such a way that the difference here, the error, is minimized. And that's how AI systems are trained. Now, let's talk about something which is better than converting kilometers to miles. ChatGPT, how does it do this computation? Well, it takes all the textual data in the world. It has a huge data set, and it tries to see based on this data set or based on these questions, these answers are actually best answered when I take all these parameters, fiddle around with them till it makes sense. And that's how a big system like ChatGPT can also be trained. It's all about having a number of these parameters. In this case, it's just one, but in many cases, there's 50,000 or 100,000 of these little knobs and dials. You move those knobs and dials ever so slightly to reach a combination that's able to produce an answer that makes sense. And in essence, that's how this linear system works. Now, we talked about moving that 0.6, 0.7 slightly. How does it actually look? Because surely it's not moving random numbers, right? Well, yeah, you're correct. It's not moving random numbers. Let's say our actual data point is here. This is what we're trying to predict. And this is our input. What we're going to do is imagine this graph right here. This is the length, this is the width. We take a line and it's moving fast. It reaches here, the first point. You're like, well, we need to move a lot more. So based on how far you are from the actual point, you move based on that difference. So the difference between the loss back in the two slides, by the way, this error in AI terms is called loss. So anytime you go out and see an AI presentation after this and they talk about minimizing loss and increasing accuracy, it's basically talking about reducing this error so that our AI system performs better and better. But we saw that the error here is 2.137, but the error in this case was 12.137. So our AI system knows it can take big jumps right now because the error is so big. But when the error starts to get smaller, like in this case, it knows that it's close to the answer, and now it starts taking smaller jumps. And that's how you decide how much you're gonna wanna move. So it's not actually random how much you're moving, but it's saying that, okay, if I move large step in one case, and if I actually come close to my answer, maybe I should start moving slowly now in either case to see, oh, well, this is in the neighborhood of where the actual should answer lie. So yeah, this is the slow movement, and this is the big jump. We know we're not close to our answer yet because it sees, well, this difference is very large. So we'll actually try to take a big jump and see, am I closer to my answer now? If I am closer, well, I'll take smaller turns. And if I overshoot again, I'll take smaller turns in a different direction. So this optimizes our system so that we're not just going slowly in the hopes that we reach our point. We're actually overshooting for it and then adjusting ourselves so that we come close to it. Now, if after this presentation, you actually go and learn about neural networks in their very basic arithmetic sense, you'll see that overshooting and undershooting is a very important concept that is not only employed here, but in many other different cases. So it's important to have an idea about what those terms actually mean. Now let's look at the big picture here, right? The bigger picture was this neural network. I'm going to explain to you now, how do those knobs and dials turn in a structure like this, in this neural network? So all it's basically doing is, you saw that input, right? This is the input. Keep this in mind. This green dot, and we're just looking at this one synapse right here. This one connection can be thought of as one synapse in a neuron. We're going to take a look at this exact 3-arrow system, and we're going to see just from this example, how does it actually work? We're going to call this our input, this is our little black box, and this is our output. So what ends up happening is it's getting this input A. What it's going to do is it's going to multiply A with the weight W, and it's going to put a function to it. Now, let me explain on this whiteboard here how it works. Let's say you have an input 1 here. In this case, I'm going to multiply 1 with W, so it becomes W1. And then W1 could be anything. It could be 2, 3, 7, 10. But then I'm going to take these numbers and I'm going to squish them so they fit between 0 and 1. Because what you want is AI systems to have a good reference, right? If you have a random system, just a random system, predicting very, very large numbers, it's tougher to tell how good or bad you are because the difference in those numbers might be insanely large, right? A random number generator could choose even 1 million or it could choose 500,000. How do you actually quantify that you're doing better or worse when the gap between the numbers is so large? When we talked about inputting random numbers and seeing if your AI algorithm is closer, for computers, it becomes way easier if the reference scale is smaller. So all these numbers right here, we want something like a sigmoid threshold function to squish them between 0 and 1. So computers can see, oh, well, my answer before was 0.7, now it's 0.6, it's getting closer. But when you say my answer was 200,000, now it's 100,000, it doesn't actually tell you anything. And that's why we're applying this sigmoid function. And we're actually going to see what this looks like.
Ayush, I love this very thorough explanation about the theory of artificial intelligence and neural networks. How do we use this as teachers of language? What is the, in terms of the quantitative metrics of AI, how could this be applied to language in terms of getting sort of asymptotically closer to the meaning or to something that we might be looking for in a particular word choice? How would you use this for language learning applications?
Yeah. So in terms of language learning, I'd look at it from two perspectives. There's a theoretical perspective of how humans actually learn language. And there's the practical perspective of, okay, how can I use this to make my students learn language better? Let me talk about both of those questions right now. Well, for the first one, how does language work? We always talk about language and we consider language to be this given. I'm talking words and apparently you can understand it, all of you can understand it. I come from a very different place in the world, but somehow I've learned this structure of words to make these sentences that apparently make sense. We can actually use something like this AI system to break language down into seeing what are the components of language that actually make language what it is. So you know how I talked about having an input and producing an output? Your input could be just string of words and the output could be deciding meaning from them. And it's actually something that is very practical. This might seem like magic, taking random words and then seeing what is the meaning of these random words, but it's the research that I'm currently pursuing right now. So the input is something like, I am Ayush and I am picking up a box. These random words are just placed together. This black box, this sigmoid function and these weights are going to see how to take I, how to take am, what are the weight to them, right? So which word actually is more important than the other words, and then seeing what is the meaning that comes out of them. For a sentence like I am Ayush and I'm going to pick up a box, you might think, well, every word is important, it has a meaning. For a computer system, you know what's actually important? Two things, Ayush and box. From these two words, Ayush and box, it can very accurately predict that there's probably a boy named Ayush and a box, well, he's probably trying to pick up a box. So deciding these weights in the context of this theoretical application actually makes you understand, well, what are the words in language that actually are what they are and why they are what they are? Why do they have meaning? And what words have more meaning than others? So talking about ChatGPT, right? ChatGPT has almost revolutionized for the basic consumer how we think about language. You would have never thought 50 years ago that if you type numbers on a screen or if you type words on a screen, it's actually going to talk to you like a real human. There's actually a game where all you do is type sentences into this AI system, and all you're trying to see is whether there's a human at the back of that or whether it's an AI at the back of that. Think about that situation right now. We've reached a point in our lives where it's tough for a human to differentiate whether it's a human talking to them or whether it's an AI system talking to them. How did we reach this place? Well, we reached this place using a system like this. We took random words and we told the computer system, well, tune these dials and knobs to a point where what you output actually makes sense. You can think of it as a monkey on a typewriter. If you train a monkey on a typewriter enough, and if you give it enough time, statistically, there's 100% chance that it's going to end up producing Romeo and Juliet. Now, this might sound like a weird analogy, but if you actually give a monkey infinite amount of time and a typewriter, just by pressing random words, there's actually 100% chance that the monkey ends up producing Romeo and Juliet. That's almost how you can see AI. It's not necessarily a monkey, but it's a monkey with a little extra brain and some human guidance. And we're trying to make it produce Romeo and Juliet. So that's the practical application in terms of theoretical application, in terms of language learning. Practically, I'll have my friend Ryan explain to you how you can actually use these AI systems to learn and understand language better. But coming back to the sigmoid functions, I think practically it's very important to know what they are, because as we see artificial languages becoming more and more mainstream now, and for those who don't know, artificial languages are languages made in this day and age to make communication easier. They're constructed from the ground up. Every single word and every single conjunction in them is made up, and they're made up in such a way that it makes more sense. And the way it makes more sense is decided by these weights and these functions. So coming back to what I was saying, a sigmoid function takes these large numbers and squishes them down between 0 and 1. So you can tell that you're closer to the answer or you're far away to the answer. Anyone has any doubts in how this works? Taking a number, multiplying it, and then squishing it between 0 and 1. Easy enough to understand, right? Well, you're actually closer to understanding AI than 99% of the people in the world. So what actually ends up happening is you have these inputs, you have weights here, and all an AI system does, it is multiplies the numbers with these inputs, and it tries to control that multiplication factor in a way that the output it produces here. And basically, this is W times 1, this could be W2 times 1, W3 times 2, W3 times 4. Just multiplying numbers with different numbers, and on each step you're adding them together. You're adding them together in such a way that when you change the weights, it ends up producing a number that makes sense. And that's all AI is. In the very, very basic sense and in the actual sense, all an AI system does is it takes these weights and it changes them around so that when you add these weighted sums together, it ends up making a number that makes sense. Now, this is practically what that's sort of looking like. Let's say I choose a weight 3, I choose a weight 1. If I multiply 1 with 3 and 2 with 1 and squish it between 0 and 1, let's say it gives me 1. It's going to be some other output here. Well, we see, okay, the output that the AI system's giving me is actually 3/4 away from what it should be. And on this side, it's 1/4 away from what it should be. Now, as we discussed earlier, we're going to change these weights just a little to make these errors basically disappear. And that's a neural network. This neural network is those numbers and those losses being computed together. You actually know now, you might not realize this, but if you were to go, you can take this very concept, put it down by hand on a whiteboard, fiddle on with the numbers, and end up making ChatGPT. It might be a very long process, but that's actually how it does it. Now we're going to do a fun little demo. If you could just scan this QR code for me, and I'm going to have this pull up on my laptop screen. Does anyone want to see the QR code again? It's basically it's teachablemachinewithgoogle.com. Teachablemachinewithgoogle.com, and it'll be actually really good if you could follow this with me. If you pull it up on your laptop, it should be slightly better, but I'm going to give you a demo here as well, so you can follow along with me here. I'm going to go, and this is, by the way, a great resource. If you want to see what you actually learned today in action, this is theory of applying that into something that works. There's an audio project here, and we're going to talk about the image project today because that's literally the most fascinating one. Now, I am going to build in front of you an AI system that can predict whether I'm throwing a thumbs up or whether I'm throwing a victory sign. Right now, in front of you, we're going to build an AI system that can differentiate between this or this. So,
Quick question.
uh-huh.
How does the victory sign, is it just this is victory, this is peace? How do you differentiate victory and peace?
Well, that's actually a good question. For this purpose, I'm going to claim this as being victory.
Okay.
But that's a very good hypothesis. You could train an AI model to differentiate between victory here and peace here.
Okay.
So that's an interesting project. You can actually try it out on your system when you're making that AI model with me, and I'm going to show you how it's done. So let me call the first class here victory. Let me call the second class here thumbs up. Now, remember when I said a mechanical Turk has workers trying to classify images, whether they're dogs or cats? You want to give AI enough sample points that it can learn what makes a cat cat and what makes a dog dog. In this case, I'm going to give it pictures of both victory and peace to show it what victory looks like and what peace looks like, so it knows what it's doing. I'm going to turn my video cam here. I'm going to allow it. I'm going to take a bunch of photos of me showing the computer a victory sign. Now, if you see, I'm actually trying to move my hand around in different ways because the more variety there is in my pictures, the less bias there is in the AI system. And after this demo, I'm going to talk a little bit more on the ethics side of what bias is in terms of AI. Well, my AI has 56 pictures of a victory sign now. Let me give it a thumbs up. Okay, now I'm going to press train model, and hopefully it should do the magic trick where it can differentiate between a thumbs up and a victory sign.
You should think your Zoom share screen may have frozen here. Let's see.
Oh, it should just be lagging.
It's lagging a little bit. Your processor is working in overdrive.
yeah, my processor. Okay, let's give it a second. Or should I just share it again?
Yeah, I think if you stop the share and then share it one more time, it'll work.
Okay, so now you can see it has a preview here and it has victory or a thumbs up. If I don't do anything tangible, it's going to predict basically nothingness into victory or thumbs up. So the answer might be a little confusing, but actually let's show it a thumbs up. Look at that.
That's incredible.
And this is trained in front of your eyes. Remember when I said there's going to be inputs, there's going to be a little magic box here, and there's going to be an output? Well, this is what it looks like for an actual example. It's taking these images, it's applying weights to them, so it's multiplying them with some number, and it's basically changing those numbers till it thinks that I can happily predict a thumbs up versus a victory sign. That was my presentation for today. Before I end up wrapping things up quickly, I do want to mention ethics and bias in AI. It's an important topic that often gets overlooked, and it's actually something that you were talking about when you talked about a dystopian world, right? So in a very practical sense, what that dystopia looks like is very different from what people actually imagine it to be. And it's actually sad what the dystopia looks like in current age. You know how I talked about adding variety to my data set and showing a victory sign in multiple positions? That's almost how humans are. Humans come in a lot of varieties, right? There's different colors, there are different races, cultures, forms of speech. Something like Siri, that's an AI system that is predominantly trained on, let's say, the American accent, now does not know what an Indian accent sounds like. So because for an AI system, all it's trying to do is mathematical computations on making an output most similar to the inputs. If you give it an unknown input, in which case it would be an Indian accent, it can't actually get what the person's saying if it hasn't been trained on a data set of as many Indian accents as American accents. This is a big problem that persists in AI to this day. Different languages, for instance, ChatGPT is very, very well trained on English just because of the plethora of English that's out there. But something like a local African language, you bet it's going to have a lot more difficulty. Now, with this technology, do you guys think that its use should be restricted to English and Western speakers? I don't think so, because it's a very universal technology. And on the very scientific sense, if we let it, you know, affect the global north, like industrial revolution did, is going to increase that gap between the haves and the have-nots. AI, as we all know, is going to be the thing that powers every other thing in the future. And if at the base of all the operations, there exists a technology that is predominantly race sensitive, we're in big trouble. So I implore you guys to talk about, whenever you see AI, ask yourself a question: what data was this AI trained on? What was that data very inclusive, or was that catered to one audience? And now when you start to look at systems this way, you're going to uncover a lot of things you might not have thought of in the past. For instance, when you search up Indian marriages on Google Images, it might show a very different picture in different contexts than when, for instance, you search up American marriages. Another example, if you search an African boy having fun in Google Images, I would personally expect to see a picture of a normal boy having fun, but you might see grim examples of someone living in poverty. Now, I never asked Google to show me those images, but if it shows me those images, the AI system has not been trained well. Now, Google actually is one of those companies that's putting a lot of effort into increasing AI literacy and into reducing bias. But anytime you ask a question, generally now, you should have the back of it in your head. In the back of your head, you should have a thought of whether it's answering a question to me very well, and can the same AI model answer a question to someone from a different demographic as well or not. Moving from that slightly grim thought aside, I'm going to have Ryan now talk about language learning practically and how can you use AI systems to learn a language more effectively. Ryan, take the show on. Oh, by the way, does anyone have any questions so far? Okay.
All right, after Ayush's very good overview of how AI actually works, I'm going to show you some use cases for how this can be used in our classrooms and in language learning. Of course, many of the things I'm about to show you can be used for daily life or other subjects, but I've tried to cater them all towards college learning languages. So I'm going to go through three general things: personalized learning, increased efficiency, and gamification. Gamification, obviously, trying to make language learning more fun, more enjoyable, trying to memorize all those thousands of vocabularies. And we're going to try and increase efficiency, how fast we can learn it, and personalize our learning. Maybe we're a verbal learner, maybe we learn more through listening, maybe we learn more from writing, and AI can help us with all of that. So first of all, personalized learning. I'm going to quickly show you CNoChat, which is a tool that will tell you how to plan for, say, a midterm, or plan how to learn certain grammar points in like a certain amount of time. And then I'm going to show you a very good way to make thousands of flashcards within a few minutes. I'm personally a big flashcard learner, which is why I've included this, and I've used ChatGPT myself to learn Japanese with these flashcards, and so I think you might find a lot of value out of it if you actually learn too. This is CNoChat here. As you can see in my prompts, I've asked it to help me learn 100 Japanese vocabularies within a week. I've sort of used a few things in these prompts. At another time, maybe if I do more, we do more PowerPoints in the future, we can go in a little bit about what makes a good prompt and what makes like the ChatGPT or CNoChat give you the exact answer that you want, or even a unique answer. But besides that, this is my prompt trying to get a plan for the next week. It laid out day by day what I need to do in order to learn 100 vocabularies, and this can be used for grammar points, or this can be used to help me learn enough for my midterm coming up, if I have got one. It's definitely a fun tool to play around with, and a very good scheduler.
Very quick question there. Can you go back to that previous slide?
Yep.
So create a plan to learn 100 Japanese words. Are these just random Japanese words? Have you uploaded the list somewhere?
Oh,
Yeah,
so this is just general plan that
Okay.
I wanted just for 100 words.
got it.
If I really wanted to, I could first of all put in like all the vocabulary that I want to learn. Just put it into the system. I'll say like organize all this vocabulary for English on the left side, Japanese on the right side. I'll lay it all out, and then I can ask an additional question after that. So it has the Japanese and English in its memory, and then I can say, okay, with these words, what is the best way for learning if I am more personalized towards writing down? And it'll give me maybe a few fun ways. I can ask it for a fun way to learn it. Like you can really have fun for exactly what you want. Like I think being very specific is one of the keys. You don't want to be too broad about what you want from these chatbots. Here is what's helped me a lot this semester, creating hundreds of flashcards within a few minutes with Anki. I'm not sure if you've heard Anki before, obvious? No? Anki is pretty much just an online flashcard app. It's like a tool for your computer. Normally, you'd have to sit there and type all your English and then the Japanese after, but this will do it all for you immediately. So first of all, you're going to copy and paste a prompt. I can give you this prompt afterwards. I think it's actually going to be in the Global Studio website. It's in the whole quick start tutorial for this. But you're going to copy and paste a prompt, and then you're going to copy and paste all the vocabulary for your subject. Then after that, you're going to ask ChatGPT to put in a CSV file, so it'll just separate it all by comments. It'll be neatly laid out like that little black box there. And I'll have a little option for copy code. Then just going to copy and paste that into a notepad for a PC, or I'm not sure what the Mac equivalent is.
Text edit, most likely.
Yeah, text edit, something like that. Going to copy and paste it in there and save file, just put it in Anki's, and boom, you're going to have 1,000 flashcards, which is going to look something like this. This is what my day looks like most days, just on there, going about. Of course, AI can also increase efficiency. One of the tools which I'm about to show you is actually what helped me and Ayush a lot during the summer as we're trying to do research for if an AI bot would work. Of course, we had to go through lots of Zoom meetings for that. We can get more real life scenarios. Sometimes, for me personally, it's hard to get more Japanese conversation without trying to go to my professor and practice. So tools like this can be great. And then we can also have it summarize grammar points when we're not really truly understanding, which can happen.
So Ron, one more thing I just want to interject with the transcripts. I've used that on Zoom calls before, where I'm teaching on Zoom, and the microphones are almost too powerful, where if I want to have a private aside with a student about a grade, I think this could have been a lot stronger, this is what you got to see. You almost have to think to yourself constantly, hot mic, because you don't want the transcript to pick up private asides with the students.
Yeah, I'm sure there's probably a way to get around that, but
Okay.
that sounds yeah, definitely be careful with that. But yeah, this is one of the tools I will take the transcript for you. This is the tool that me and Ayush used. Essentially, Fathom for Zoom meetings. I believe there's also TLDR, which is a competitor to this, which I believe works equally as well. I just prefer Fathom personally. But it will take a whole transcript of your Zoom meeting. It will identify different voices. So it'll be like, oh, this is speaker 1, speaker 2. You can add names to them if you want. And it will summarize the key points of the Zoom meeting. And obviously with the transcript as well, you can copy and paste it into ChatGPT. I actually did this with Ayush over summer. Obviously you want to be careful and make sure there's no mistakes. So when you do it, obviously go through it again. But for example, over summer, I copy and pasted transcripts of my interviews with sales professionals. And then I asked for the quantitative statistics of that interview with the copy and pasted transcript. I just lay down the facts without me having to scroll down like 1,000 words worth of just pure language. So the next one, Quasel, which is essentially like a Duolingo app, except it's chatbot for speaking and having a conversation in a language, I believe is about 20 times better. Duolingo hasn't really properly got that in a personalized way. There are many chatbots that can be used for specific languages. For me, AirFriend is a Japanese bot which can be very specific and tailored towards language learning. If you want to find a bot like this for the specific language that you're learning or teaching, then it can be very easily found on the web as well. This is me asking ChatGPT to break down a Japanese grammar point that I was struggling with a little bit. It can give you all the context behind why that grammar point even exists in the first place, which helps intuitive understanding, as well as just teach you the breakdown of how to use that grammar point, what situation, and really grasp a good understanding. Sometimes in class, it can get very hard for me to understand a very complex grammar point. So sometimes I do come here and try and figure out with ChatGPT. Oh yes, and yeah, you can mix this with Anki as well. ChatGPT can mix grammar points. It can do pretty much anything that you want it to do for the flashcards.
Ryan, before we get to gamification, can you go back to that slide on quizzes there?
Yep.
I just wanted to show there's one resource that I've loved as a teacher called Quizalize, which is actually you can use it. It can be scaled to the actual proficiency standards.
Oh.
So I had one. Here's one Spanish, and I'm actually just going to create a quiz. The ChatGPT is wonderful. As a teacher, I'm sort of overwhelmed a little bit by that blank cursor. Like it's so open ended. I'm not quite sure where to start.
Yeah.
And so Quizalize kind of makes it. Let's start a new quiz here. We'll call this Spanish, aligned to a standard or skill, and you can select the actual curriculum here. So select subject. We'll go down to Spanish, and it's just a little bit more guided than the open framework of ChatGPT. So select grade, it's probably a proficiency level, intermediate, and then you can start. So showcase an awareness of errors, use known language to compensate for missing vocabulary, and it'll take a few minutes to process a set of questions. But I didn't mean to interrupt you, Ryan. This is just one that for making quizzes, I've really enjoyed. And honestly, we're in this mode where it's like the Wild West. There are so many tools out there, whether it's Fathom.
Whether you're producing like
quiz
or just like a comprehension quiz.
Yeah, so here it's going to generate. How would you ask for a spoon in Spanish? If you didn't know the word for spoon and had to describe it, you can click this and kind of get multiple choice. You can also feed content into it. So like if you have a PDF or a YouTube video, you can give that as sort of a prompt, and it'll generate questions based on the material you put into it.
You have to choose YouTube video and then produce the quiz.
Exactly.
Check comprehension.
Yeah.
So could you like put in your, for me anyways, my textbook's all PDF. So could I just put in my PDF for textbook and it's asked it to fit?
Yeah.
Put in a chapter and do a review quiz.
Exactly.
Is that what you're applying?
Yeah, that do like, or just in general, just to help me before like a midterm, like just put in a. Wow, that's powerful.
So this I think I didn't mean to interrupt, Ryan, but
no, that's amazing.
This is another tool that you can add to the kit. It's called Quizalize. Sorry about that. Oh, sorry. This will all be. We'll prepare a summary that we can send out to the group.
Yeah. All right. Well, as well as Quizalize for personalized learning, it's very nice. I know we're going to go into gamification of language learning. A lot of the things that I've shown, such as the flashcards, are all gamification, as well as Quasel. Duolingo does gamification very well. I was actually talking to Dr. Bagranov for my advising yesterday, and she was like boasting about how long her Duolingo streak was, and I was like, oh, So all AI and keeps you going.
What language is she learning, Ryan?
French.
French.
Yeah, I used to use it a lot, but since I came here, I've lost my Duolingo streak and demoralized me. But so yeah, as we've seen in the past, there, Chat is a great way of gamification. Just simply give it a prompt and say, okay, it's hard to learn 1,000 words of Japanese. Can you please give me a fun way of learning all these words? As well as Anki cards, very easy. It makes you feel good every time that you say, oh, that word was easy, or oh, that word was good. Just keeps you going. Next is ChatGPT for quizzes. Marshall I give an excellent resource for this. This is how you can ask ChatGPT to do it. Just copy and paste a prompt, or just make your own prompt and exactly how you want the quiz to be done. Or you can go to Dr. Marshall's app, and it will simply just give you a quiz on the vocabulary that you've given it or the textbook that you've given it. I believe here I copy and pasted all my grammar points for Japanese, and it's not the best screenshot, I will admit, but it's pretty much asking me on my grammar points, and I find it wildly helpful before going into my midterm for it. And that's just general apps for now. There's a world of apps out there, but any questions on the apps there?
Brian, it seems like most of these are browser-based tools. Is there, I'm just concerned, how do we know whether an AI tool is safe in terms of whether, we're kind of using this black box?
What do you mean for intentions?
I mean, what if you install something on your desktop and it's, in addition to scanning what you're entering into it, suppose it's scanning every file on your computer? Do you have recommendations for safety in AI? And I mean, Ayush talked to bias earlier.
I think Ayush.
Yeah, so with AI, especially, there's a reason why private equity public firms don't allow their employees to use AI. And it's something that I'll give my 2 cents on. Basically, something like ChatGPT, it uses what you gave it to make the entire system better, right? So if you input something like, oh, tell me how my credit card number looks 100 times, if someone else asks, give me an example of a credit card number for MasterCard, it might as well put your credit card number on their screen.
Yeah.
I would be really, really, really careful that if you're doing something extremely experimental, for researchers that could look like, is compound A very viable to treat hepatitis B? Now, ChatGPT knows that people are searching a disease and a compound in its context. When someone else searches for that disease, it might as well give the recommendation for compound A to be the medicine, which could basically be the difference in making a good research and bringing it out to the public even before it's ready. So it's really it's really important for you guys to be careful of what you're putting in these softwares or ChatGPT. Viruses, on the other hand, are a completely different thing. That's more general cybersecurity. If you're going to a website, make sure it's secured. Don't actually download tools unless you really need to. A lot of these tools are web-based, and that gives them this nice firewall that they can't break out of because everything's happening, in this case, in your browser, unless they're downloading files. So definitely prefer using web tools. Don't download random tools. AI tools, more often than not, are going to be on the web. So if you ever see a tool that seems suspiciously wanting to download on your PC, there's a very, very high chance that it might not be something that you want to download. So Google, does this tool actually need to be on my PC? But in a more general sense, each of these tools that you use, that you saw here Ryan talk about, it uses to some degree or the other ChatGPT as its backend. And the same knowledge applies here. If you're putting your research paper before it's been published into this system, there's some chance that ChatGPT might use your PDF to answer someone else's question, which might leak your knowledge.
Yeah.
So be careful about that and use these tools responsibly.
We feed lines into ChatGPT and doing the system.
Well, it's funny that you bring that up because
Bad French to it.
that's happening. That's happening as we speak. When ChatGPT 4 first came out, Harvard statisticians found out that it gave an answer which was way more accurate and precise because it was trained on gold data to like compared to what it gives now, because it has a lot of people have been using it,
Right.
and the answer that it gives now is more clouded with human ignorance than it previously was when it was just trained on like gold data from the internet.
Right.
So it's actually happening in daily life. These models are actually getting dumber the more they interact with humans,
Yes.
which is a food for thought.
I actually seen a thing the other day. A guy was convincing ChatGPT that 2 + 2 = 5. I took about 10 lines, and ChatGPT was like, "Oh, sorry for the confusion. I now know that 2 + 2 does equal 5." And then right after, he's like, "Oh, what's 2 + 2 then?" And it says 5. That's ChatGPT is getting fed some.
Well, you can't convince the entire system that 2 + 2 = 5 because there's just so many documents in the world that write 2 + 2 as 4, and I'm sure it has an arithmetic system built into it. But for your chat context at least, or if let's say you're working with a simpler AI system, you can actually convince it that 2 + 2 = 5 because it doesn't actually know what 2 + 2 is. It's just trying to predict in all the situations where I've seen 2 + 2, what is the most likely answer that the documents give me. So if you feed it all the documents where it says 2 + 2 = 5, it will give you 5 as the answer. For someone like a data scientist, it's really important to feed it the right data, because if you don't feed it the right data, it's not going to give you the right answer.
I also just want to give a sort of a shameless plug for there's a tool called There's an AI for that. Most of this is grounded in ChatGPT, but it's like this is the new Google for how do you search for tools, whether it's AI for video creation. There's a tool that allows you to describe a product, and then once you define the product according to your parameters, you can actually order it directly from Shopify. We are on the precipice of just everything changing.
Yeah. And day by day, if researchers are more interested, me and my friend are making a retrieval augmented system, which basically means instead of trying to go off on what is the most likely outcome that this document's going to give me, we're actually trying to pick out excerpts from document that exactly answer a question to what you're asking.
Yeah.
So for a researcher, like what drugs are useful to treat coronavirus, it's actually going to pick out every single drug that's been mentioned in the text about solving coronavirus. It's going to pick out an excerpt from the text where it's actually stating that this drug is useful for treating coronavirus.
There's a scholar out in Silicon Valley, Jacob Glanville. He's oftentimes quoted as being Netflix epidemiologist. He was one of the first people to start applying big data to just what you're looking for, like the designation of protein relationships.
Yeah.
How do you there's so many relationships in terms of correspondences and correlation. And what that vaccine development process with COVID should have taken years when you're doing it the old-fashioned trial and error method. But AI kind of allowed us to sort of advance and think it happened in 6 months.
Yeah. No, it plays a big role, especially when you can see what compounds are being talked about for a particular disease.
Yeah.
You go from the process of having to manually go through those papers to having an AI model basically pick out the stuff that is important and skip out the fluff.
Yeah. Ayush, Ryan, thank you so much. This was really good. We have to end it here today. I would love to keep the conversation going if there's maybe an interest in doing this on a monthly or bi-monthly basis, but this was fantastic. Thank you both.
So much.
Thank you.
Thank you.
Very nice.
Thank you so much, Elizabeth, and I guess you left already.
Thank you.